Okay, so we have created our external project, and what I'm gonna do now is to modify some of the parameters for the um, training policy and the some of the attributes on the reinforcement learning algorithm, right? Since it's our own external custom project, we can change and modify it the way we want, and will not run the risk of breaking anything on the main Isaac lab project, right? So I created my project here on the root folder, and I named my IsaacLab project 7. So I think the hardest part here is actually to um, understand where things are saved in the folder structure. And once you understand that, everything becomes easy, right? So it's a little bit convoluted at first, but there's a logic behind it. So on scripts, inside the scripts folder, you'll see the two types of algorithms that we chose to have our external project support. And then if we click on one of them, we'll see the train.py file, right? So this is the main script, which opens Isaac Sim and kicks off the simulation, and also starts the reinforcement learning pipeline behind the scenes, right? So this is the guide, the lead or controller, if you will, of the whole training pipeline. If you go back to your project folder, you'll see the source folder, right? So this is where we can find the parameters for the reinforcement learning algorithm and also the training policy. So you just have to go through all the uh, folders with your project name, click on tasks, and here I'm running a manager based type of project. I'll explain in future videos the difference between direct and manager based. And remember that on the last video, I suggested to change the name of this folder from whatever your project name is to carpol, because it contains a carpol simulation here. And here we have, once we open carpol, the first file that we'll see is this one, your project name, environment configuration, right? So this is a file that contains everything that Isaac Sim needs to build the environment, but also the reward policy for your robots and for the training, right? So what a reward policy is, in a nutshell, is it defines what the robot gains for doing something right and what it loses or how you punish it if it does something wrong, right? So this is a carpal a task. So the main goal here is to have the cart balance the pole on an upright position, right? So and then you have 5 types of reward functions to push the robot to achieve this goal, right? So the first one is the alive reward, which basically just rewards the robot with 1 point every time step that it stays alive, right? So as long as it remains alive, it gains 1 point for each time step, which is sort of like each frame of the training simulation, right? The second one is the failure or terminating penalty, which is sort of the game over penalty, right? So every time the robot lets the pole it just bounce downwards, then it loses 2 points. That's why the weight of this reward is -2, right? And this is the primary task that we want the carpal to reach, which is to keep the pole upright. And for this, we are giving a punishment of -1 If the pole angle distances itself from the target, which is 0, 0, right? So the 0, 0 angle is the pole upright on a 90-degree angle from the floor, and this function is calculating. So whenever it distances too much from this, it gets -1, right? And these two tasks are just here to make sure the robot execute these functions in a smooth manner, right? So this one penalizes if the cart moves linearly too fast. This one penalizes if the pole is like wiggling around too fast. So it's a penalty for high angular velocity, right? So this is basically um, how you teach a robot through positive and negative reinforcements with rewards and punishments, right? Just like you would teach a child or a dog. So what I'm going to do is that I'm just going to alter some of these here. And I'm not really concerned about the effect on the training performance or the results here. I'll just put whatever just to show how we can modify these attributes, right? So let's say that I really want to avoid the game over, avoid the robot from like failing, then I can just increase this to a much higher number of penalty -10. And I also want to give a higher penalty here for the pole not being on an upright position. Let's say that I don't really care about the robots moving smoothly at all, so I'll decrease these penalties here, and this will not be reinforced, right? So I can just come here and save this version. And now I'm going to change the parameters for the reinforcement learning algorithm, right? So if we come here inside agents, we have the one agent for each one of the algorithms. Here I'm running RSL and PPO algorithm, and each one has its own parameters, right? So we can come here and change any of them. So I'm going to change my learning rate, increase it. So learning rate is roughly how fast the algorithm tries to reach a point of minimum error. If this is too fast, it will just blow past this point and will not find the optimal point. If it's too slow, it will take a long time for it to reach an optimal learning point. And then you can also change the, let's say, the clip parameter. So the PPO algorithm has something that is unique to it, which is you can control how different the new policy is from the old one. And you want to do this if you want to prevent very abrupt policy updates, right? So let's say that you are controlling a robot and the movements are just about right. You're afraid that if you run this training again, then the robot will just like go crazy and start like moving like very like dangerous or half-star ways. So you want to make sure that any new update is kind of similar. It doesn't differ too much from what you already had before, right? So this clip parameter sort of means that whatever new policy here will be only 20% different up or down from the past one, right? So let's say here that I'm not really concerned about this. I'll just put, okay, so it can be up to 50% different. And the entropy coefficient, it's sort of like an exploration coefficient, or like how creative the robot can get in its moves to try to reach its goal, right? So it means like how much exploration it can do, and kind of like how crazy it can go, or like how crazy are the movements that it can try to reach its final goal, right? So if this is very low, the robot will be like very conservative, will only try like moves that are kind of working right. If this is high, it can be like very creative and try like very unique moves for a carpal task in which the robot here doesn't have many degrees of freedom. It's not a very complex simulation. This wouldn't make that much of a difference. But if you're talking about like humanoid robots or any tasks that have objectives that are more complex, then this can have an impact, right? So I'm just gonna change these three parameters here. Click on save. And after I do this, all I need to do is to run my task again, right? So I'm here back into my Anaconda prompt. I have my environment activated. I'm in my root folder, and I just run this command that is basically saying go into my project folder and run that train.py file, which, as I said, is sort of like the script that leads the whole training pipeline, and then run this task here. And then it will run with the parameters that I have just modified and saved. So you can see that it will start running. It will open IsaacSim. There you go. And here you have the episode rewards, all that it's doing, right? So as I said, I wasn't like really concerned about the results, but that was just to show how you can change this, right? And just to test that this is actually using the new parameters that I created. I'm just gonna pause here. So as you can see, this training session is running for 150 iterations. This is also a parameter that we can change. So if we go here in the reinforcement learning algorithm attributes, we can search for max iteration. So instead of 150, I'll just run for 50 here. Save. And if I run that again, then you'll see that it will show that it will only run for 50 iterations and not 150. So IsaacSim has started with simulation, and as you can see, the learning iteration attribute here is counting up to 50, right? So just to verify that it's using the attributes from the file that I modified myself.